Good evening, gentlemen and ladies. Hope all is well. Thank you for joining a little bit belatedly this SubQuery workshop. I'm going to bring Boris onto the stage. We are deep into the depths of this hackathon. We have sent you an email on yesterday asking for an update about your projects so that we can provide one-on-one tailored support to you. Please do reply to that email. It is from a Dwight Schrute, which is our general encode. We're going to reach out to your email and then you'll be passed on to a program manager at Encode who's happy to do a call, messages, or minimally kind of make sure you're on the right track with the project. All the workshops, of course, are shared with you guys. I think yesterday might be a little bit slow, but if you're itching to get it, please DM me. We're delighted to have Boris from SubQuery today, a long-term partner of Encode. So we're delighted to welcome SubQuery back, and Boris is going to talk to you now. If you have questions, yes, chat is recognized. I'm an Arsenal fan. I'm a Gooner. Off to Madrid tomorrow, so it won't probably be with you in the evening, though I think that workshop, there's a secret source, has been at least delayed, not because I'm in Madrid, but kind of helpful. Okay, so if you have questions, you're going to use the chat or the question function. I don't mind which, and we'll deal with them. I know you've been very vociferous in your questions throughout recent weeks, which is great. Well done. So let's go from there. So Boris, over to you.
All right. Hey everybody. So testing these slides. Hopefully they work. Hello. My name is Boris. I'm representing SubQuery in Europe, and today's session is somewhat interesting. So I've tried to design it to be more. We're going to be more spending more time in VS Code than probably with actual theory. And I was also exploring like a lot of things the first time myself, and I was trying to somehow design this workshop to be as beginner friendly as possible. So and try to simplify some of the things that we decide to showcase. But anyway, thanks a lot, Encode, for the ability to talk to have this workshop. I hope it's going to be great. And yeah, so the name is Creating Custom Indexes with SubQuery SDK for AI-Driven Insights. The agenda, as usual, split into two parts: a theory and practice. The theoretical part, I'm going to be talking about like the use case for indexing in general, in case you don't know what indexing is, describe some of the features of SubQuery. On the practical part, is also consists of two parts. We're going to be going over a couple of examples of the project, the indexes built for various examples, and then we just and then I wanted to showcase a natural language queries over the indexed data set. Starting with theory. So indexes, what are the indexes? Indexes are essentially a middleware between the blockchain and the applications, which are allowing essentially the apps to get the historical data from the blockchain. So let's say you want to be developing an app and have some kind of a statistics page there, and you want to be powering it with the historical data, so something that happened like a million blocks back. So it would be problematic to obtain it like from the client each time from a block that happened like long time ago. So instead, you can use a replicated version of a blockchain with a filtered data. So only the things that you actually need, and fetch some data in a single request, which would be much faster for the apps and easier to deal with. So that's what you're using the indexes for. So the index is essentially a service that iterates like block by block, collects data, filters out, handles it somehow, transforms it, finally saves it to some kind of a database or any medium, and then it's giving just an access to it via any possible interface there. Why SubQuery? SubQuery is open source. It's Docker friendly and therefore very easy to get started with. Simple. Only 3 types of files need to be configured. Customizable, built on top of TypeScript language. You're getting the flexibility of TypeScript. It's very fast. It's packed with various features that are helping to enhance your experience, and specifically the speed with indexing, as well as the minimize the potential errors that you may have during the execution. Real time, so instead of polling, you can connect via WebSocket and receiving the new data on the fly. It's multi-chain, so simultaneously from multiple blockchains, you would be able to handle data and essentially provide a single API endpoint. This is particularly interesting for the cases when you're dealing with cross-chain execution. So let's say bridges, and you want to be tracking the execution on like all side of the transaction. So essentially a source chain and the target chain. And specifically with XCM, you're not only having like now usually you have only 2 blockchains that you have to deal with, but even more so. You can easily work with multi-chain that part. Flexible, so not only you're able to deal only with deterministic like blockchain data, but you can also use the third-party libraries or APIs, for instance, to fetch the prices, and you're getting the whole flexibility. And finally, SubQuery is compatible. It's compatible with several architectures, including EVM, including PVM, which is EVM compatible. So, and the substrate network architectures. It's really easy to start with indexing. So you will only actually need Node.js to run the indexer itself. If you want to be launching it with Docker, you would have to have Docker installed. And if you want to simplify the things for yourself and use the official templates provided by SubQuery CLI, it's also recommended to have the SubQuery CLI installed as well. Quickly over the indexing configuration steps. First, if you're using a CLI, you can initialize a project with template using SubQuery in it. And then a second step, build. Only 3 types of files need to be configured to set up your indexes. So you define the shape of data with a schema file. Essentially, it's you're manifesting the API schema with this file. With the manifest file, you're configuring your endpoints and filters, and essentially the instructions to fetch the primitive data from blockchains. By primitive data, I mean like blocks, calls, transactions, and events. And finally, you transform this primitive raw blockchain data with something what's called mapping files, and saving it. You transform them anyhow you want to transform them, and save them anyhow you want to save them. And then essentially those are small examples of the schema, a manifest file and mapping files. I'm going to be giving the specific examples. I'm going to be going over the specific examples. So you'll see in details how exactly they are working. Finally, you just query, and out of the box, there is a GraphQL service that is coming together with SubQuery indexes. So, but you're obviously having a freedom of choosing your own interface to query data. Demo time. Are there any questions so far that I can answer before I proceed to a demo? Okay, infinite loop. Hope it's not too bad. All right, then proceeding to demo. So I'm having I'm having everything organized in VS Code so that it's visually friendly for everyone. And what I wanted to showcase are three indexes. And the first indexer is a multi-chain indexer that handles data from three different networks. This is Asset Hub, Kusama, and Polkadot. And the schema, the specification is very simple. So we're only collecting the transfers. And together with transfers, we are saving some additional data like a generic substrate account, which we can calculate from the account address on the specific network itself. And the manifest files for all three networks are similar. So what you're only having like different Genesis block hashes, obviously, and the RPCs. But apart from that, everything is different, and only a single mapping file, essentially a function that transformed this raw data to something more meaningful, is used. So how is it called? Yeah, it's called handle event. So essentially what's happening, we are getting in a raw event from a specific blockchain that we're just passing it to the same function that is essentially handling it and populated it either with a proper network name. I'm actually missing Asset Hub here. I don't know why, but all right. So if we, all the steps regarding the run of the projects are well documented in the SubQuery documentation. So, but just to quickly mention the main commands, there's SubQL codegen, something that used for code generation, TypeScript code generation. For EVM specifically, it's very useful, and Solidity contract. It's specifically for Solidity contracts. It's very useful as well because you're with the codegen feature, you're getting the TypeScript types generated based on ABI, and this is all done with that command. And with types generated, you're getting essentially a security of not having your project failing during the runtime when the issue is caused by incorrect types handling, obviously. The second command is build, so you just build a project, and the third command is to start a Docker. So I'm going to be launching everything with Docker. So this is all packed within a single command called def. So codegen, build, Docker pull, and Docker up. Simple. So I'll need to cd into a correct folder. When I run this command, I'm having codegen. I'm having the everything built. Essentially, the Docker run. So then when it starts, we are automatically getting. Let me see if I'm having all the containers spin up. We're automatically getting a web view for GraphQL server. So as you remember, we're only having two entities that we're populating, which are transfers and accounts, and we can query them correspondingly, and having the schema fetched automatically. So it's very easy to essentially, you don't have to remember your schema by heart. You can just select the necessary parameters here, just like that. So, and as you can see, we're getting a bunch of events indexed on Kusama. I don't know if we're seeing anything in Polkadot, but yeah, not in this query, but yeah, this project is multi-chain. So yeah, obviously the best case is cross-chain execution, but not limited to that. This was a first example. A second example is compliant with the main theme, with one of the main themes in the ecosystem, Solidity smart contracts on Asset Hub, specifically Polkadot and yeah, things related to that. So yeah, let's deploy a smart contract on West End. One of the greatest sessions that happened last week with Serial was about smart contracts. So you should be familiar with the essential basic tools for that's helping during the Solidity with development of smart contracts on Solidity, and Remix is one of those tools. So what we're going to do is deploy a storage default smart contract that's found here. One thing that I was added is an event name. Is a specific event that we want to emit during the execution of store function. So this event itself is having two arguments, the address and essentially a value that we store. Once we, yeah, we can, I think we can compile it quickly and then have it deployed. Hopefully it works. Okay. I hope it's gonna be, yeah, it has deployed, hopefully without issues. So this is the Explorer of West End, of Asset Hub on West End, and we can query the contract. We can get the visually get the simple visual details about the contracts that we've just deployed, and yeah, only 27 seconds ago. And now we can start to store some data there. And this is one of the explorers. So it's a block scout, which is an explorer compatible with all the EVM compatible networks, and therefore compatible with Asset Hub on West End. So you're able to see the blockchain data here. But not only you should be able to see it here, but also in Subscan, since essentially, yeah, Asset Hub on West End is a substrate-based, substrate-compatible chain. So essentially, we're having two architectures within the same network. And from SubQuery standpoint, since both substrate and EVM architectures are supported, you're able to work with both of them. And on substrate side, there is a Revive palette that is having some of the events, and we can actually get some of the important data to the index from those events. So more details are in the official smart contract tutorial. But yeah, we're only going to be working for now with ETH transact and the payload, this specific, yeah, this specific string here. So far, we've deployed a smart contract. This is the address, and we can start storing some numbers there. I don't know, let's pick 140. Let's store 140 smart contract. So a new event should appear here. Yeah. So what we've done is, called a function, and we've also used a certain number as an argument, which is this one. And this is what we can see from the EVM Explorer, from the in the Subscan Explorer. We're seeing a similar data. So if we navigate from this specific transaction to the list of events, we can see that essentially everything here matches. So that's the account address. That's the value that we've inserted. We can quickly double check it with the hexadecimal to decimal converter. So this means 140. So that works. And if that stores, and if that being saved, if that's something that's being emitted as an event on the blockchain, definitely this is something that we can index, and therefore this is something that we can provide a historical access to, aggregate, and do anything with it. So yeah, I can store some additional numbers, like 170 probably, and we can proceed to indexing. So what we can see from this transaction is the block where we had it deployed, and therefore, since we're indexing the specific contract, we don't have to start with from the block one of the blockchain. So we're having a freedom of picking it and putting it as a start block. I'm having two examples prepared for smart contract indexing. First, we're going to be using a SubQuery EVM node and EVM node indexer, and then we're going to be doing the same with a SubQuery substrate node indexer. So with EVM, it's pretty simple. Again, starting with a schema, we're only going to be storing in database a number. We're going to be saving the transaction hash as well as the block height and number itself and the sender. So essentially all the data that we can obtain from the blockchain. Here we, sorry, wrong one. Here a manifest file, so a EVM manifest file. We're getting the chain ID from the env, so that's the chain ID, that's the endpoint that we're going to be connecting to. It doesn't have to be a public endpoint. It could be, of course, the node that you're running locally, or any private node provided by from various companies. Yeah, so it doesn't matter what you really put here. And you're not also limited to using a single endpoint. You can also use several if you're worried about losing a connection to a node for some reason. So let's put a start block to the block deployment. And the thing that I was mentioning, the types based on ABIs. So I'm having with where is it? With this small smart contract, there is also an ABI that is coming. So ABI will is having the following look. So essentially, it's a metadata for the contract itself. We're seeing that here's our custom event that is present here in ABI, and the event itself is having two params: the address, the address of the sender, and the value. And we're also having some metadata for the functions. So what does it mean? It means that if we put and somehow reference it here in the manifest file, we're having the types automatically generated. I'm going to be showing you exactly what does it mean after I change the smart contract address, which is different. And this is this is the one here. Yeah. And then finally we proceed to the handlers. So essentially a TypeScript functions that are going to be accepting the raw blockchain data and somehow try to handle it. So we're having a single handler called handle_log, which could be found under mappings. And what essentially does, it logs something, and then it just creates a entry in the database populating with certain data. So for instance, for ID, it's using the transaction hash. For the block height, it's using the block number. For sender, it is deconstructing the args of the event of the log. And same goes for number, just a different arg is used, and then it's being converted to the big integer. Finally, it's being saved. All right, so a codegen and type generation specifically. So as you can see here, we're importing something that's called number stored log from a folder types ABI interfaces storage. So you got this thing, you got this specific file generated automatically based on this ABI. So if you try to access the type definitions, we can see that this specific type is essentially having this structure, and therefore, and it's having this specific parameters that are custom to our smart contract, and that we can easily access with the structure like this. And it's not, as you can see, it's not showing any errors, so it's totally fine, and we're ready to launch it. So I'm having it called, does it have EVM, and then I just run it. And as always, being worried that something goes wrong during the live demo, but it seems to be working fine. Let me please expand the view here. So the indexing has started, and we can already try to query the database. So this is a query from the previous case that we've seen, but since we were no longer having transfers in the schema, it's showing this error, but we're having a specific schema now for our new project that we can select and query. So I've called smart contract twice, I think, or 3 times, I don't remember. But anyway, those are the params that we've essentially placed here in Remix. I think we still have, 170 was the last one. So we have only probably queried it 2 times, but you're seeing this data. So the sender and the numbers that we've put. You can achieve the same thing with a SubQuery substrate node. And for that, I'm also having a separate project prepared, Asset Hub Substrate, which is very similar to a EVM one, but obviously you're working with Substrate now. So as chain ID, you're now having a Genesis hash. The RPC is, I think it's different from the EVM one. I'm not sure. Yeah, it probably should be. But anyway, that's the same blockchain that we're dealing with, and essentially the same data, just different VMs of it. So here we also have to change the start block from current one to this one. And as you can see, the kind of the project is substrate project now. And we're not mentioning the specific event topic. We're mentioning the filter. We're doing the filter on the substrate on the palette and the methods being called. So I don't know. I think VS Code should allow us to compare the selector. Yeah. So that's essentially the difference. So substrate project here. Here we are not mentioning the specific address of smart contract. Instead, we're just going over all the events, over the contract emitted event of the revive palette. So yeah, that's not really different from the one that we had for EVM. And the mapping file is very similar to the one that we had. It's just, oh, sorry, wrong file. It's just, yeah, a bit different. So there's a different way that we deconstruct the event, but essentially we get the same data. So npm run dev to essentially codegen, build, and run everything in Docker. And we should be having the same data visible in the GraphQL Explorer. So let's see. Hopefully it works. Oh, I think I know what is the issue. I've previously commented out some of the Docker components. So if I switch them on again, now wait for the GraphQL server to start. Should be. Okay, let's just wait here. We should be getting the same data. Yeah, I'm seeing some of the logs already here. If we just refresh the page and query, yeah, we're getting the events indexed. Yeah, I think I've selected the wrong block, but anyway, we had one of them indexed, so hopefully, yeah. What I was trying to preview is that, yeah, you're essentially able to work with either SubQuery nodes and, yeah, achieve the similar results. This is the end of practical session part 1. Are we having any questions that I can answer already before I switch to a second part? All right, I'm not seeing any questions. So yeah, so academy.subquery.network is the best place to learn more about indexing with SubQuery SDK. So be sure to check it out. A second part of the demo session is AI-powered analytics that is fully local. And so far we've been having our stack totally local, except for the RPC node that we were obtaining the raw blockchain data from. But we can also leverage a little bit of AI, for instance, for AI-powered analytics. And if this is a common scenario that I've been currently showcasing, then in the second part, we're going to be removing a GraphQL and replacing it with something what's called an agent, LLM, and the user itself. Sorry for this visuals, last minute visuals. And the whole process is going to be looking the following way. So in parallel, we're going to be having the indexing SDK handling the blocks. So receiving the blocks, transforming the data, saving data to the database, marking the block as indexed, and then having it essentially in loop until until blockchain is switched off. Yeah, essentially infinitely, just constantly populating the data. In parallel, yeah, we're going to be having a small agent developed, which isn't actually like a real agent, because we're going to be controlling most of these steps, specifically the one about decision to proceed with a suggested SQL to execute, but it could be obviously totally automated so that you don't have to make this decision. So what we're going to do, we're going to be querying a data set with natural language. So so I'm just going to be writing a simple queries there. Then the agent, essentially a small Python program in my case, is going to be giving it to the locally hosted LLM, which is Olama in my case, and a Gemma model specifically. So if you're interested, Gemma free, this one. Then the LLM is going to be returning it a generated SQL that I'll be able to review manually and decide to proceed or not. If I decide not to proceed, the process is aborted. If I decide, if I see that the SQL query is valid, yeah, the agent will execute the SQL on the database. It will fetch essentially the details, and finally it's going to send the results to LLM for interpretation. That way, essentially requiring a user not to worry about like any technical specifics like SQL query or GraphQL query. So it's quite easy to set up. So I'll simultaneously run the indexer and the agent itself. Also, I'm having the Olama running, so we're good to go. So before I run the indexer, I'll quickly go over the small Python snippet of the logic that I've just described. So LangChain is being used in that case. So LangChain is an AAP framework, which simplifying the process of building the AI apps drastically, and quickly going over the code. So I'm connecting as an LLM. I'm using Gemma Free with Olama as a provider, which is hosted locally. I'm connecting to a database that is being run in a Docker container. So this specific Docker container. And then I'm having essentially a state, then I'm having essentially a state. So a question, there is a query, SQL query, and there is a result, and there is an answer from the LLM that interprets the results. As a prompt, I've picked something like this. Again, this is this session is not giving any specific suggestions regarding a specific code being used or specific architectures. Rather, the goal is to showcase how simple is it to actually start the on-chain data analysis without the knowledge of really any specific technical stacks or programming languages. So it's really easy to set this all up. And the second goal was to just show the beauty of the software development state in 2025, where we actually don't have to develop anything from scratch anymore, but rather use the components already available out there. So 3 steps that we're having. A query. We essentially we ask the LLM to provide us with a SQL query based on the specific query. And we're also giving it a table schema, obviously from a Postgres database that we're using. Once it's done, we're executing this query. And finally, we pass the execution results to a LLM again to generate the answer again in the human readable form. We're using some of the tools of LangChain. Specifically, we orchestrate the functions that we want to be calling. So we want to be calling them synchronously. Write, execute, generate, and yeah, at certain after the write, after the LLM provides a SQL, I'll be able to yeah, decide whether we should proceed with that or not manually. So if I now run the indexer on the tab that is on the left, and on the right side, I'll prepare to run our small, it's not an agent, small Python program that it's leveraging the locally hosted Ollama. First, let me please make sure that we're having the database populated. So just picking some random data. Yeah, again, this is the data set from the first example that I was showing during the indexing SDK demo. So that's the data we're having. And now we can start querying it. I'm having some of the queries prepared in advance. So let's just go one by one. In the meantime, please, please suggest your own queries that you want to be playing around. So starting with how many times the number was, that's an incorrect query because this is the one for a smart contract case, but for multi-chain transfers, we can use that one. How many transfers are stored so far? When I run this script, it's not working for me. How cool is that? Is it? I think. Is it Ollama that's? I'm having it run. I don't know why it's failing. Oh yeah. So this is it now. Hopefully my computer doesn't die after having all of the things run. But yeah, this is a SQL query that LLM suggests us to use for that specific human query in a human readable language. And I think it's good. So let's try. If I type yes, then it should make a request to a database and fetch a result, and then we get a result in a human readable form again. So the SQL query counts all rows, blah, 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 shows that there are 67,000 transfers. Again, let's run it again. We probably have more transfers generated now in those couple of seconds, and the query is the same. Tap yes again, so the number is different now. How much is it? 3,000 additional transfers were indexed since then. Let's take more complex queries like what are the account IDs and substrate and generic account IDs of top 3 transfers with a hashed amount. I'm also asking to fetch the specific data like transfer ID, sender ID, and the generic substrate ID. What does it mean? It means that it will have to use several databases, several tables from database, because like our initial schema is having the following look. In the transfer entity, we're only storing the receiver to an account that is not in SS50. I'm always confusing it. That is essentially chain specific address, and then we can essentially derive the generic substrate address, and we're having it stored in a separate table, so it should be doing the table joins if it works. If it works fine, so let's try it. Let's wait for the SQL generation. All right, we got the SQL. Select the ID from. Yeah, I don't think that it's returning the substrate generic account ID, but let's see. I mean, it's returning some data, but not the substrate generic account IDs. Okay, let's help it. You might need to use to join tables. Let's give it a small hint. Again, that heavily depends on the selected LLM and specifically the hardware that it's being run on. My computer is unfortunately not that. It's not having the greatest software. Maybe that's one of the reasons why it's failing. But let's see what it does after we hint that it might want to join some of the tables. I run the script once again. And it doesn't work, and it doesn't join the tables. But you have to trust me on that one. It worked for me when I was testing it right before the workshop. Switch to another example. So let's query now. Let's switch to a different data set. Let's query the smart contract. Again, I'll switch to a different indexer. Then I'll start running it. There is a small thing that I have to yet manually change here. So a schema multi-transfer is used. This is a specific name that I was giving for a multi-chain project, but if the project is single chain, Asset Hub West End in our case specifically, then it's usually app by default, but obviously it could be specified separately. So what are we having in the database? In the database, we're having in total, how many of them? Total 2 entries. Let's create a new one. Let's add 1,000. Let's store 1,000. Okay. So I think it's fine now. Yeah, that's the event. Let's see if it was indexed already. Yeah, here it is. It's indexed already. And now, again, we can query it the same way as we were doing it with the multi-chain transfers. We've having a single query prepared. How many times the number was stored so far? So let's try to run the script. And again, hope that it's gonna work. Select, count everything from number stored, also ordering and limiting. All right. It didn't really work. Why not? How many times so far? Okay, let's help it. Don't use limit and don't use order by. Select everything from, yeah, let's see how it goes. Yeah, and as you can see, it's returning that essentially we stored a certain value to a smart contract 3 times. And yeah, it matches completely what we're seeing here, only 3 nodes. Yeah, I think this is mostly it for the demo part. And again, what I was trying to showcase is both the possibility of indexing the smart contracts, the ability to cross them in AI matter, and yeah, happy to answer any questions if there are so far.
Nice. I don't know if you've handled all the questions throughout, Boris, but there's a few in the chat.
Okay, so am I able to somehow pull them to the screen or no?
Very good functionality. The fact they are not on the questions tab means no. You'll just have to read them.
No. All right. How is SubQuery decentralized? So what I was showcasing is the TypeScript SDK. Essentially, you can run it anywhere. You can run it on your own premises on Amazon, or in third-party centralized indexing services, as well as the decentralized indexing infrastructure called SubQuery network, which wasn't a part of today's workshop. But you're essentially having a freedom of choosing the method to have it run. Are there any feeds that aren't just price feeds? Well, anything from Web 2. I don't know if you're having some relevant info from any endpoint that you can essentially query and get the data from, then you can use this data within SubQuery indexer. What about cross-chain in indexing? What about cross-chain indexing? So cross-chain indexing is something that is accessible via a multi-chain feature of SubQuery. And there are plenty of examples in the GitHub, so be sure to check them out. Do you support all the parachains? So SubQuery supports not specific parachains, but rather architectures. So if it's a substrate-based parachain, or if it's a substrate-based parachain that is having a EVM-compatible VM like Frontier or Polka VM, then yes, SubQuery can index such kind of data. If you're having Cosmos VM on a parachain, that would also be possible to index that data. Is SubQuery different from subgraphs? So subgraph is a indexing SDK, is an SDK for indexing development, I think maintained by dgraph. There are plenty of differences between them. One of the most noticeable one is, first of all, SubQuery is a asynchronous framework. It's TypeScript based. It supports multi-chain, but like the most comprehensive comparison between SubQuery and the graph could be seen in SubQuery documentation. You'll be able to see the comparison table there. It's quite a big one, so you'll find all the necessary answers there. What is the pricing? So depends on the method that you want to choose. So one pricing for decentralized infrastructure, the different for the centralized. Yeah, you'll find all the details online. Can you receive the fees of the feed I create? Well, as long as your feed is queryable, of course, that would be possible. How do I run a substrate node? So substrate node is, you'll probably need to specify here. So substrate node is probably substrate, SubQuery substrate node, indexing node, you probably mean this. So be sure the best way to proceed is to use the SubQuery CLI, just type subql init, and then you'll find the templates for Polkadot that's having only the substrate index and node examples there. What applications use SubQuery? Well, mobile wallets, explorers, dApps, and any app that requires any kind of historical data handling, and not only row transactions or row events. So something that was handled somehow. What AI functionality do I have? SubQuery doesn't really have the AI functionality out of the box. So, but you can have a subquery within your AI stack, just like the one that I've just shown, with the LLM hosted locally or anywhere. A question, what is happening? I will answer that. How can we improve the agent so that we don't need to review the SQL commands every time? I think, yeah, I'll need additional time for that. So I can provide a code snippet or a gist in Discord channel. I think that's the best place to share it, right, Anthony? Or what would be the best way to communicate with the community? All right.
Yeah, works well.
Perfect. Can we also index for uploaded contracts on West End Asset Hub? Of course, you can do it. I'll have to share the screen once again. Of course, yeah. So just pick any contract from here and see its ABI. Although having its ABI is not really necessary, you just need to see its events and the all the contracts functions that you want to be handling, and yeah, you can just pick any. So you're having the whole freedom of choosing which contract you want to be, or contracts you want to be indexing. What is the URL of West End Asset Hub block scout? It could be found in official contracts documentation accessed by contracts. I think contracts.polkadot.io. You'll be able to find it there. Can we even know how to open the Polkadot wallet? I don't know what exactly do you mean here, but I think it was the last question.
Nice, Boris. Thank you very much. Anything else you'd like to add?
No, really. Was excited to be here. Excited to answer the questions if there are any in Discord. I'm there until the end of the hackathon and looking forward to the project submissions. And yeah, thanks a lot again, Encode, for a possibility for us to do something different this time. Experiment a little bit with AI. Try to simplify things for the beginners. But I think it was a good session.
A fantastic workshop. This will be available tomorrow, guys. Thank you very much, Boris, for your time. Perfectly on cue as well, perfectly within the hour. And we will see you all tomorrow. Thank you very much. Bye-bye.
Perfect. Thank you.